Hey guys, it's Miss Landry, and today, this is the second video for lesson 1.4, all about the atom. In this video, you're going to learn how to read the periodic table. So when you see like that square with the information in it, what does it mean? And how can you figure out how many protons, neutrons, and electrons are in each atom based on the periodic table? So let's jump in. First of all, we're going to go through different parts of the square that you see on the periodic table. The first one we're going to talk about is the atomic number. It can be in different places depending on what periodic table you're using, but it's always going to be the smaller number without a decimal. So that's the atomic number. This is what determines what element it is because it tells you the number of protons. So you cannot change the number of protons without changing the element. So for example, carbon has six protons. So remember that this indicates the element and the number of protons. Now, if it's neutral, which we are going to assume, unless I tell you differently, assume it's neutral, that means it also tells you the number of electrons because remember, protons are positive, right? And so if I have 6 of them, that means I have 6 positives. Okay, so picture that, that's in the nucleus. I have to balance that out somehow with some negatives in order to have 0 charge or be neutral. So that means I have 6 electrons in the cloud outside of the nucleus. Because remember, electrons are negative. So those have to kind of balance each other out to create a neutral atom. So the atomic number, unless I tell you otherwise, tells you how many protons and how many electrons. So protons and electrons. Okay, so carbon has 6 protons and 6 electrons. So now let's look at the name and the symbol. So the symbol will be letters, and then obviously the name is letters too, but it spells out a word. So carbon is C. What I want you to, there's 2 things you need to know about the symbol. The first thing is it's not always the first letter of the word. So in this case it is carbon C. But sometimes it's not. Gold, for example, is AU, silver is AG, potassium is K. There's lots of other ones. It can be named based on Latin. It could have been named based on where it's found. So remember that there are some weird ones on the periodic table where the symbol doesn't match the name. So some of those you're going to have to memorize. And when we write the name and put things together, so if I have a symbol with 2 letters, so for example, cobalt is CO, you're going to capitalize the first letter, and then the second letter is always lowercase. So like molybdenum is MB, so it would be capital M, little b. Magnesium is Mg, so capital M, little g. And the reason for this is if you look down here at the bottom of this slide, let me highlight it for you. I love the highlight. So yeah, and let me close that. Okay, so carbon monoxide is a carbon atom with an oxygen atom, one of each. And so we know that that's carbon monoxide because they're 2 capital letters. So it's 2 different elements, 2 different atoms. Versus cobalt, which is also CO, but notice it's a capital C little o, and that indicates it's still just a single element. I hope that makes sense. With practice, this will get a whole lot easier, I promise. Oh, okay, let's go back to clicks. Okay, atomic mass is on the bottom. This is kind of the last thing I want you to know about the periodic table, so, well, for this lesson. So notice it's a decimal. We're going to go into why it's a decimal down the road. And the mass is in something called AMU, which we'll also go into down the road. Just remember that the atomic mass is always the larger number. So if you notice, carbon is 6 and the mass is 12. So this mass is calculated based on the number of protons plus neutrons. So you add them together. So this is the mass of the nucleus. So protons plus neutrons. So let me go back, sorry. Remember that all of the mass pretty much, except for like the smallest little bit that doesn't actually count, is in the nucleus. And so atomic mass is found in the nucleus. And what's in the nucleus? protons and neutrons. So we add those together to get the mass. Okay, so let's summarize. If you know the atomic number, so here's molybdenum. Oh, sorry, I said MB before, it's MO, like Missouri. The atomic number tells you the number of protons, and it also tells you the number of electrons because we're going to assume it's neutral. If you know the atomic mass, that tells you the number of protons plus added together the number of neutrons. So the question is, how can I find the number of protons? Easy. It's the atomic number. So here it's 42. That means it has 42 protons in its nucleus. How about electrons? Well, remember I said we're going to assume it's assume it's neutral, meaning it doesn't have a charge. So the negatives, electrons, have to equal the positive, protons. We already know there's 42 protons, so there has to be 42 electrons. So that's pretty easy. Okay, well, how do I find out how many neutrons there are? Okay, let's go back to what's in the nucleus. Protons and neutrons, right? I know the mass, I have it right here. I'm going to round it to 96 because that's just an easier number. You can't really have a half of a subatomic particle. So we're going to round this to 96. If I subtract this mass from the number of protons, I'll be left with whatever's left in the nucleus, which is the number of neutrons. So in order to get the number of neutrons, you just subtract the larger number after rounding it from the smaller number. And that's it. Here's a little practice. Go ahead and, this is, excuse me, in your packet, I believe on page 13. So go ahead and tell me, I need to know the number of protons, neutrons, and electrons for the following elements. And we will go over this in class. Thanks, guys.